Today we're going to talk about applications to geometry and literal equations. We've been talking about word problems and applications, and we're going to continue with that in Chapter 1, Section 3. So before we start doing some examples, I just want to review some vocabulary. Perimeter, of course, as you recall, is the sum of all sides of a shape. So I like to think about the word rim in there, and the rim is all the way around the edge, and so that's essentially what you're doing, is finding the sum of all the sides all the way around the edge. And then we have complementary and supplementary angles. These are two very common definitions that sometimes get mixed up. And so I'm going to offer a mnemonic device. You guys know me and I love my mnemonics, to remember the difference between complementary and supplementary. So if someone gives you a compliment, it makes you feel all right. Right angles measure 90 degrees. So complementary is 90 and supplementary is 180 degrees, the sum of the angles. And then of course we know that the sum of the angles of a triangle is 180 degrees. Okay, let's go ahead and start right in with some examples. The first example, we have the length of a rectangular corral is 2 feet more than 3 times the width. The corral is situated such that one of its shorter sides is adjacent to a barn and does not require fencing. If the total amount of fencing needed is 774 feet, then find the dimensions of the corral. So if you want, you can go ahead and give yourself a quick sketch. So here's my barn. And then essentially my corral is off to the side here, and I know this is not necessarily accurate looking because we're looking, that would be like kind of looking down on it, and so I have a mix of dimensions here. But we know that we don't need to fence in this side because the barn takes care of that. So we really just need to fence these 3 sides. Okay, so we know the length is 2 more than 3 times the width. So we'll call this the width, or W, and then this would be 3 times the width plus 2. Okay, and so now this other side here would also have the same length. It does tell us the shorter side is adjacent to the barn, so we don't need to cover that one. All right, so we know that W plus 2 of 3W plus 2 is equal to 774. And again, you could do it either way. You could do this plus 2 of them separately, or 2 times them. Okay, and then we'll put into practice all of our properties. So we're going to go ahead and distribute. We have W plus 6W plus 4 is equal to 774. And then we'll go ahead and solve. So I'm going to do 2 steps at once. I'm going to go ahead and combine my like terms on this side, and at the same time I'm going to subtract this 4 so I can start to isolate the variables. So here I have 7W equals 770. Okay, and then we'll go ahead and solve for W, inverse operations. So it's 7 times W, and we'll go ahead and divide. So now I have that the width, or W, is equal to 110. And this, of course, is feet. And then I have my length, which is 3W, or 3 times 110 plus 2. So we have 332 feet. Okay, and then you can go ahead and do kind of a quick check there. So does 332 plus 332 plus 110 equal 774? And it does, so it's check. Okay, the next example is dealing with complementary angles. One angle measures 10 degrees less than 4 times the other. Find the measure of each. And so again, I like to draw myself a nice little picture. I know complementary means that they add up to 90, so I have my picture here. And then I know these 2 angles, one of them is much larger than the other, so I might put in a split here. We have one angle, which we'll call x degrees, and that's the smaller. And then the larger angle is 4 times that, minus 10, or less 10. Okay, and together we know that they add up to 90 degrees. Okay, so we'll go ahead and we'll combine our like terms. We have 5x minus 10 equals 90, and then we'll work through and isolate our x value. So we're going to add 10 to both sides. We have 5x equals 100, therefore x is equal to 20. So one angle, the smaller angle, is 20 degrees, and the larger angle is equal to 4 times 20 minus 10. And then we want to just double check. 20 plus 70 is equal to 90. So those are two examples of our geometry applications, and then the last thing I want to talk about before we end our video is literal equations. And literal equations are just equations that contain more than one variable, and they're usually used to represent a formula. So for example, area equals length times width, or perimeter is 2 of L plus 2W, or circumference C equals 2 pi r. So you have a C and a pi, and an r. And a lot of times you'll be asked to solve for one of the variables and then maybe continue with the problem from there, and or just isolate that variable for any number of purposes, and we'll review and talk about more of that in class. Even though there are more letters in the equations, you can still apply the same methods that you always use for solving equations. You'll still use inverse operations to undo and to isolate a particular letter. So let's take a look at an example. In this example, we have essentially perimeter equals 2 of the length plus 2 of the W, and we're being asked to solve for L. That means we need to isolate L. Okay. So I'm going to first start by moving everything away that's not directly connected to L. And so I have a P minus 2W equals 2L. P, 2W, they don't have any like terms, so we can't combine anything. And so from there, we're going to go ahead and try to get L alone. We have 2 times L, so to undo the multiplication, we will divide. And so now I have that P minus 2W divided by 2 is equal to L. And you can leave it in that form. If you wanted, you could do P over 2 minus W, but this is perfectly fine. All right, that's all for tonight. Tomorrow in class, we'll put all of this into practice. Thanks.